Alright, welcome aboard the GEM, the Japanese Experiment Module aboard the International Space Station. Today, I'm going to be doing an activity with our Astrobee robots. So we're just getting started. I'm actually going to call the ground here soon, check in about exactly what we're doing today. I know we're doing some gesture recognition work and testing out that software. And we will get going here. Should be a good day. Huntsville Station on 2 for Astrobee. Penny, thank you. I copy, switching to 3. Huntsville Station on 3. Good afternoon, Eric.
Hey Woody, great to be with you. How do you read me right now?
Hey Eric, great to be with you. I have you loud and clear.
Today's activity is in preparation for a student event that's going to be held on next week. And we're going to be running ops with you again. So today is going to be a dry run for that event. This is a project called Zero Robotics. Are you familiar with Zero Robotics?
Yes, I've heard a lot about Zero Robotics. I think it's just awesome that we're going to have students involved in writing code that's running up here on the space station. I'm really excited for it. Today,
what we're going to be doing is, for each run, you're going to be performing 3 hand gestures in front of the Astrobee, in front of the science camera. And you're going to want to be about 30 to 50 centimeters with the hands in front of that science camera. That's the sweet spot. I would say closer to 50 centimeters than 30, but you'll figure it out as we go. We'll be back with you. We are ready for cruise step 2.2 to undock Bumble and place in the base 6 area, and then we'll fire up the impellers.
Eric, I copy. Inward. All right. Just pull it off the dock here. And the home position is right about here. We'll just let it go there.
Woody, that was a great first run. We're very excited here on the ground. The next run is going to be numbers 3, 4, 5. Are ready when you are.
Eric, I copy. I'm ready for 3, 4, 5.
Stand by for flashlight. Woody, that was a successful run. We are ready for the next run. The numbers will be 3, 5, 9.
Eric, I copy. 3, 5, 9.
Stand by for flashlight.
Alright, so after I put in the gesture, Astrobee does some position and orientation changes in response to the numbers that were displayed in front of the camera. Alright.
We're ready for 469 again.
Eric, I copy. Standing by for 469. So the last run, the classifier misidentified 469 as 464. So we're going to give them this run again and hopefully provide some more training data. So I'm waiting for this little flashlight on the front. There it is. That's a 4. That's a 6. And that's a 9. Now we'll get out of the way. Let's see what they got. You can see a little bit of detail. These are the vents. They're blowing out air all the time, but the little movers in there open and close.
Woody, this was another interesting one. We visually saw 469, so you're doing good there. The robot saw 465 this time, so very interesting. Stand by for a decision to rerun again, but again, part of the data.
Yeah, that's really interesting, Eric. I'll be standing by. Alright, so it sounds like 9s are hard to classify. What I don't know is whether the team on the ground is building this classifier for these gestures and providing it to the students as a module or software package that they can use, or whether this is the task the students have, is to classify what gestures the robot is seeing. So it'll be interesting. So you can see some detail here on the Astro Bee. There's fans running, blowing air through the vehicle all the time, and then there are these little vents with little louvers inside that control, open and close to control how much airflow is coming out. And there are, looks like 2 on each side. So 2 on the bottom, 2 on this back face, 2 on each side, and so a total of 12. That gives you control authority for both position and orientation in 3-dimensional space. And then on both sides there's a sort of whole suite of sensors. The side that I'm avoiding right now is what it's using for navigation. There's a nav camera up there, and then there's also something called the science camera. That's what I've been doing these gestures into. Back here on the back we have a dock cam and a perch cam. This is the side of the Astro Bee that docks to the charging station, and it can do that autonomously. And then there's also a perching arm that can be configured onto the Astro Bee, and it can do things like perch onto handrails. So it's a pretty cool vehicle, and it's a great platform for things like student competitions. Just a really versatile, reliable platform for doing cool stuff up here.